Hey everybody, Mr. Barry here. Moving into the fourth unit on polynomials. We've already taken a look at evaluating them, and now we're going to be talking about roots in this situation and different things that we can pull from different looking polynomials with focus on ones that have been higher than our quadratics. So here, looking for real roots, degrees of polynomial, and the y-intercept. We'll talk about it in this particular problem here. Y is equal to the quantity x minus 7 times the quantity x plus 2 times quantity x minus 3. The roots here should hopefully be something that you're familiar with. It's what we've done in the past. We're applying the zero product property to what we see right here, and it's nice and done up so that we've already had things factored. We could see the factors here, x minus 7, x plus 2, and x minus 3. So the real roots should be the zero product property applied here. So I know that my x value is here. If I have x minus 7, it should be positive 7. If I have x plus 2, it should be negative 2. And if it's x minus 3, I should have positive 3. I'm not trying to really get too crazy with that. That's something that is pretty familiar to us. Degree of a polynomial, different type of question here. What I'm doing is trying to figure out what the largest exponent would be in the problem. If I were to multiply all of this out, what would be my highest exponent? So I'm going to take a look specifically at the x values here. There's an x value here, here, and here. I'm just going to copy those down. I'm going to show you what a multiplication would happen. I'm not doing the multiplication out in great length. I'm just trying to figure out what would be the biggest exponent in this polynomial. So I have 3 x's there. That works out to be x to the third power. So if I were to go ahead and multiply everything here, I would have an x to the third power. So that means that our degree for this polynomial is the number 3. That's one polynomial that if you have a exponent of 3 as your largest exponent, that's how we call the degree, we would call it a cubic polynomial. Finally, the y-intercept, slightly different idea. We know what the y-intercept is. We know that's when our graph crosses the y-axis. But here, a shortcut to figure out what the y-intercept would be if we were to have to plot the point. So we know it'd be 0, comma something. What would that something be? I'm actually going to look inside the parentheses. So I have negative 7, 2, and negative 3 as constant numbers in the parentheses. I'm going to take those numbers and I'm going to multiply them out, because if I multiply those 3 numbers there, again, the ones in the parentheses, negative 7, 2, and negative 3, not the ones that we have for the roots, but what we actually see up here, negative 7, 2, and negative 3. If I multiply those out, negative 7 times 2 times negative 3, I believe that would be 42. 42? Yeah, 42 sounds good. So our y-intercept would be 0, comma 42. Not necessarily the greatest thing to graph. Need a relatively large graph for that one, but we do know that the y-intercept there would be 0, comma 42.